Let's begin by creating a folder called cache. Let's go into the folder. Inside the folder, let's create another file called cache.c. Let's understand the cache problem. Here, we need to receive an input, which is the value of the change owed. Then the coins available are 25 cents, 10 cents, 5 cents, and 1 cent. Our task is to find the least number of coins that can be given as change. The output will be the least number of coins whose sum will be equal to the change. So, for example, if we have to give a change of 88 cents, we will need 3 25 cents, 1 10 cent, and 3 1 cent coins. That is a total of 7 coins. Now, let's begin by including the libraries that we will be using. Hash include stdio.h and hash include CS50.h. That's .h, not .c. Now, let's write our main function int main void. Our first task is to create a function that will prompt the user for an input and then validate the input to see if it is a positive integer. If it is a non-positive integer or if it is a letter, we want our algorithm to prompt the user again to give the correct input. So inside our main function, let's create a variable called int change. And let's make a new function whose output is an int, and let's name it get positive int. There will be no input to the function. Let's initialize a variable called number inside it and create a do while loop. Inside the curly brackets of the do loop, let's use the get int function to prompt the user to enter the amount of change that is owed. Change owed. You have to repeat this while the number is less than or equal to 0. Less than 0. So sometimes the change owed is 0. Okay. Now let us create the prototype of this function. Let's call the function get positive int. Now let's see if it is working properly with made cache. There is an error. It is in 17. What is the error? Non-void function does not return a value. After it, return num. Let's make it so. Make it again. Make cache. Change owed is 8. It functions well. Let's try it again with a negative number. Prompts again if we give a negative number as input. So our first task is complete. Our next task is to find the least number of coin. If the change owed is between 25 and 100, we'll subtract 25 and try again. If it's between 10 and 25, we'll subtract 10 and try again. If it's between 5 and 10, we'll subtract 5 from it and try again. If it is between 1 and 5, we'll subtract 1 and try again. We'll try until the change owed is 0. So we need a for loop. Let's first create a for loop where int I is equal to change, and we'll continue the for loop as long as it is less than. We'll continue the for loop as long as it is greater than 0. Inside this, let's create a set of conditions as earlier specified by the pseudocode. So first we have to find out if the change that we received is between 25, that is if I is greater than or equal to 25, and I is less than or equal to 100. If I serves this condition, then we want to make sure that I is equal to I minus 25, and we can shorten this and write it in this way, minus equal to 25. We also need to create another variable. Let's call it int number of coin. Let's make it so that for every subtraction we have to increase number of coin by a unit of 1. Now let us create else if it is between 10 and 25, we want 10 to be subtracted. Let's do it again. Let's do it once more. If it is between 1 and 5, we want 1 to be subtracted. And with that, we have created our function, which will run as long as I is greater than 0. As long as there is change, this function will be called for again and again and again. Let's make the make cache once more. There are a number of errors. Let's look at it. Number of coin plus plus. Variable number of coin is uninitialized when used here. Give it a value of 0. Number of coin. Let's make cache again. Call cache. Cache old. Let's type in 88. The answer is 7. Nothing is returned. We haven't made a provision to printf. Let's printf %i \n number of coin. Let's make cache \cache. Change order is 88. The answer is 7. And with that, we have completed our algorithm and the cache problem is solved. Let's check how let's validate our algorithm using check50 CS50 /problems . Oh, there are a few faults. Input of 160 yields the output of 7. Did not find 7. Input of 2300. Why did we get this wrong? There must be a reason. There's always a reason. Let's look at our code again. What happens if it's an input of 160? For an input of 160, our code should function properly. Let's make cache once more and colon cache 160. Nothing happens. Why? Because 160 is more than 100. Because it does not satisfy any of the criteria. Let's make a change. Let's say that let's make it so, and let's call cache again. Make cache /cache. Change order is 167 ./cache. Change order is 2392. Let's call the check CS50 function again. And there you have it. We have passed all the tests, corrected our errors, and now you know. Even if you were to encounter problems during coding, you could revisit your code and systematically think through the problem to find your solution. So thank you, and wait for more CS50 videos.